So today we have a 2007 Honda Accord. It's got the 4-cylinder 2.4 liter dual overhead cam engine, and it was brought in here because it cranks slow. I see it has a fairly recent battery. I've already load tested the battery and it passed with flying colors even though the battery is cold. CCA is 450. I got 250 amps out of it for 15 seconds and it stayed above 10 volts. So the battery's not the problem. I'm going to set up here so you can hear how it cranks when it cranks over, and we're going to measure starter current draw and do some voltage drop tests. So I've set up the current clamp on the negative cable at the battery. I'm using an OTC amp clamp, and right now with the cooling fan running and the key on, it's reading 30 amps. I'm going to crank it over. I've got the injectors unplugged so it won't fire, so this way I can crank it and come back and have a look at it. Now that cranks pretty slow. It sounds pretty rough. Let's pause it and then go back and have a look at it. So it's over 200 amps. It's averaging about 175 to, this is 200 amps, 200 volts. 200 millivolts is 200 amps with this amp clamp. So the starter's drawing a significantly higher current than I would expect. We'll have a look at the voltage drops on the battery cables. It's going to measure the ground on the voltage drop on the ground. So I've threaded a PK screw into the top of the battery post, and I've got the ground clamp connected on there, and I've got the ground clamp over here on this fairly clean stud that's attached to the intake manifold, which is bolted to the block. So we should be good for ground. Mind you, understand this is not checking the starter ground to the block, but we're looking for less than probably 0.3 here on this meter when we crank it, so I'll set it up so we can read it. So here we go. I'll get ready to pause this. Crank it over and have a look at it. So this whole screen was 1 volt, I believe. I set it up at, yeah, that's 1 volt. So .3, 0.38, 0.4, pretty noisy, but it's not high. You know, there's 0.4. So we're going to check the positive circuit now, which means I got to lift up the car. So after looking underneath the vehicle, I come to realize the starter's underneath the intake manifold, way down inside there. Just wonderful. I can't even get to the battery terminal. Well, I can kind of, but I decided to look for a place in the electrical circuit where I could use a remote start button, and there is a connector under the battery, or sorry, underneath the air filter. This gray connector is an inline connector that feeds power to the S terminal of the starter. But when I got down here, I started looking at this ground cable. See, this battery ground goes to the body, and this body ground goes back to the engine block. Now, that doesn't look very healthy. Yet it didn't measure bad when I was doing the voltage drop test, but that can't be good. There's half of the cable rotted away. So we're going to fix that ground before we start tearing this intake manifold off or moving it off to the side so we can get at the starter. So there's the original ground cable from the body to the engine, and I fabricated one out of a 6-gauge piece of battery cable and a couple of copper eyes, soldered and heat shrunk them, cleaned the ground studs, ground spots, and we're going to put this cable in and retest the voltage drops. So I have my remote start button hooked up to that gray connector right underneath the fuse panel there. It's a 1-wire connector, it goes right to the S terminal. And I've got the negative alligator clip on a screw in the negative battery post stud, and I've got the positive alligator clip attached to a long rod, test rod, that I could push down and contact the starter motor and crank it over. Hold force on there. There's a sharp point on the end of this rod. It's a car antenna, that's all it is. And we're going to check the positive voltage drop. So I'll get set up for that. So I'm going between the negative post of the battery and the starter case with my test probe. Read 0 with no current flow, obviously. Where's my remote start button now? And we're going to crank it over. That definitely seemed to make a difference. It's averaging 0.13 volts, although it is slowing down. So we're going to do the same thing on the positive now. Okay, so now we're set up on the positive post and the starter battery bolt. 0.18. So there's nothing wrong with the voltage drops on this thing. Here's what I'm using. It's just a car antenna with a piece of vacuum hose slid up the hose or up the shaft so that it doesn't short out. Make a very sharp point on the end so you can get through the oxidation. And actually you can pierce the rubber boot down there on the starter battery bolt to actually make contact. So I'm not happy with the way this starter is cranking this engine. It sounds like it's laboring. Battery tests good. Voltage drops test good, although that ground cable was a problem. I'm pretty sure it's going to need a starter. So we're back working on this Honda Accord, and we're going to replace the starter. Now to do that, we have to remove the intake manifold partially. And I noticed a couple other things while I was working on this vehicle, getting ready here. Have a look at this intake boot. You can see that it's compromised, the crack in the boot. That could affect or would affect drivability. Also, this PCV hose is collapsed and sucked in, so we're going to replace that. Although they never complained about any drivability symptoms, that's definitely an issue. And again, the starter's down underneath the intake manifold here, so we have to remove the intake manifold. And you don't have to completely remove it, so we're going to try to just move it forward, closer to the rad, and basically leave all of the coolant hoses and wiring harness and everything still attached. We'll give that a try. So there are two 12mm headed nuts and 3 bolts. Disconnect the injector harness because it's going to stay. And we're going to disconnect this vacuum line to the brake booster. These are coolant hoses, so we're going to try and leave those. Hopefully they're long enough that this manifold will pull out. We'll see. Maybe I'll pinch them off and take them off completely. I was hoping to just move this forward. Oh, there's one brace bolt down there. Right down there that you can get at with a ratchet. I was hoping to move this forward, but there's really not enough room, and then there's a plastic plenum attached to this intake manifold, so I'm going to pretty much have to remove this completely from what I can see. So there's the outer intake plenum removed. There is a little wiring harness clip down here on this bracket, this one right here, that you have to undo. I did end up undoing the coolant pipes, the 2 small pipes that go down to the throttle body for heating the throttle body. I used hose pinching pliers just to pinch them off, relieve the pressure in the cooling system first. So there's the starter. Doesn't look so bad once you get the intake out of the way. So this is the control wire terminal. It should just unplug like so. Pull this boot back. This is what I was contacting through the boot with my test probe. And a little clip here. 17mm headed bolt here, and it looks like 14 mil back here. Get the battery cable off. The negative battery post disconnected, tucked out of the way, so there's no power there. So use a 12mm double offset box end to get the nut off here. There's not enough room for a ratchet and a socket because of this coolant pipe. And then there's a plastic clip here, and you can move the harness out of the way. Disconnect the knock sensor wire as well. That's this single wire. Then the harness can be moved out of the way. We tuck it back here with the tie wrap just so it's out of the way. So there's the starter removed. While we have it off, we're going to bar the engine over. Probably can turn it with this power steering pump bolt and have a look at the flywheel teeth. Another thing is this little wiring harness bracket may not come with the replacement starter, so we'll have to transfer that. I'll have to look. But that's it. 2 bolts hold the starter on. This special one is 14 mil head and the other one is 17. It's also a bell housing transmission bolt as well. So let's get the new starter. Well, what's wrong with this picture? Why didn't I look? Well, I didn't know what the starter looked like anyways. But obviously that's not the right starter. I don't know what that starter is. It's the wrong one in the box. But it's definitely not correct for this application. Let's double check the parts. Well, according to the parts information, that 91262036 is correct. 2005 to 2007. I decoded the VIN for this. I double checked the VIN. That's definitely not the right starter. Gasoline, auto trans. This has an auto trans. Additional fitments. That's a new one. That's the standard transmission. What's this one? 91262073, original design. That definitely looks better. That's the correct one. Damn. 91262073. They have that in stock. Oh man, why would they have 2 starters listed for this thing? Oh well, I guess I'm going for a road test to town. Pick up a starter. Well, an hour later and we've got the right starter by the looks of it. That's the number. Wilson 91-26-2073. So I've inspected the ring gear teeth. I'm going to go ahead and put this one in. And as I mentioned, it's missing the bracket on the back for the wiring harness, so we're going to put that on. So I've got the starter installed and I've connected the remote start button. I've reconnected the negative battery cable. And I just want to confirm that it works before I put all this intake manifold back on. That would suck if you put it all back together and it didn't work. So the remote start button here. Cranks nice and fast now. We're going to measure the starter current again once it's all back together. So clean the gasket surfaces and install a new gasket, and basically it's the reverse of the disassembly to reassemble it. Remember to reconnect that little wire harness down here, and we'll go ahead and put it back together. So there's the Dorman intake hose. It looks the same, except for this end of it has a different clamp style. It uses this spring clamp, which I'm going to have to figure out how to get on here. But otherwise we got to transfer this, looks like a crankcase ventilation check valve or something, and a couple of clamps. But we should be good otherwise. So it's all back together, ready to start. I wanted to show you where that connector is on that inline connector. I got a back probing pin plugged into it. If you lift this fuse panel up, take the 2 6mm bolts out, you can get at it fairly easy. I didn't know where it was, that's why I took the air box out before. So now I got the remote start button hooked up to that and the key is off, so it won't start. And we're going to crank it over. It's averaging around 132 amps. Like I said, it's averaging about 130. I can't remember what it was before, but it's definitely cranking faster. And you can see that's basically a relative compression test. So I've changed the air induction hose. That was a challenge to get on. And we're going to start it up. So it's all back together. I'm going to do a network code clear because I might have generated some codes by disconnecting the battery. I ended up using the 90-degree elbow that's molded on the bottom of this hose and putting a piece of regular 3/8 fuel line from there on with a union. I tried just a piece of hose, but with this cover it had a tendency to kink the hose, so I was afraid of it kinking. Mind you, it was not working before, but that's irrelevant. Anyways, that's pretty much it. Vehicle starts much better now. We got this new induction hose on here, nice and soft and supple, and the clamp tightened. Oh, I gotta top up the coolant. I'm sure it's not low, but we gotta check it.